All right, so this is basically the last thing that we are going to be doing, at least for this little mini section, which is finding all the roots of a polynomial. And this is a strategy that will work for smaller ones. You won't have to find polynomials that are like x to the 7th or anything, because that would be pretty crazy, and that is what computers are for. So for this is going to be about finding all roots to, I don't know how you want to say it, generic polynomials. So we have a list of things that we need to do. This should be your process. So number one is create a list of rational roots. And first, you want to do that by using the rational roots theorem. Actually, even before that, you want to say how many complex roots there are. So you'd look at the first term here, and you'd say, I know that there's this many complex roots. Second, we're going to check our list of rational roots until we find a 0. We do that by guessing and checking. Third, once we know a 0, we're going to use synthetic division. And then finally, if it's possible, after the synthetic division, we'll try and factor. And if not, we're going to repeat the process from step 1 again. Okay, so we're going to do this problem. I have an example problem up here on the board. This is a polynomial that is 2x to the 4th minus 11x cubed minus 19x squared minus 11x minus 21. This is not a pretty polynomial, but we should be able to factor this completely so that we are able to graph it, and also so that we just have it in a more simple looking form. So we're going to start off by using the fundamental theorem of algebra, which hopefully you guys remember, to tell us how many complex roots there are. And we do that by looking at the leading term, and we know that it's x to the 4th. So we know automatically that there's going to be, this marker doesn't work, that there are going to be 4 complex roots. So we should not look for more than 4. Otherwise, we're just being ignorant about how many there are. So we need to start off by we need to create a list of rational roots. And we do that by using the rational roots theorem. So my s in this case is 2. S equals 2. T equals negative 21. So if I do that, my factors of 2 are going to, my integer factors of 2 are going to be plus minus 1, plus minus 2. My integer factors of negative 21 are going to be plus minus 1, plus minus 3, plus minus 7, and plus minus 21. So those are all the possible integer combinations that add up to, or that multiply to 2 and to negative 21 respectively. So this means my list of rational roots, in my step 1, my list of rational roots could be, so I need to remember it's in the form of b over a. So my list could be positive or negative 1, which is 1 over 1, positive or negative 1/2, could be positive or negative 3, positive negative 3/2, positive negative 7, positive negative 7/2, and finally positive negative 21 and positive negative 21/2. Okay? So these are all my lists. This is my list of all the possible rational roots here. And if you can see, there's 2, 4, 6, 8, 10, 12, 14, 16. So there's 16 roots that we're going to have to check. The point of having this list is to be, or this process is to try not to have to check all of them. So what you're going to want to do now is you'll just go one by one in a calculator and try and figure out which one of these values, when plugged in to this equation, gives you 0. So you're going to do that on your calculator. If you want to know a calculator shortcut, come find me and I will show you a calculator shortcut, especially if you have a calculator that is like this, a TI-84. So I'm just going to start plugging numbers in until I find one. So if I plug positive 1 in, I get negative 60. That's not okay. If I plug negative 1 in, I get negative 16. That's not okay. And I'm just going to keep on doing this until I find one. So I'm going, I just did half. That's not okay. Negative 1/2 isn't anything. So these first 4 are not roots. I've already checked that. I'm going to plug 3 in. That's not okay. Negative 3 in, that's not okay. So these aren't okay right now. Positive 3/2, nope. Negative 3/2, yes, so I found one. So negative 3/2, x equals negative 3/2 is a root. So I found one. So when I plug that in, I know a root. So now I'm going to use synthetic division and try and simplify this polynomial. So I've checked my list, so I've done number 2. Now I need to do synthetic division. So I'm going to do this. My polynomial is in this form. So I'm going to do synthetic division to get a better number here. So I'm going to drop down my 2. I'm going to times it by negative 3/2. That would be negative 3. I add these two things together. That gives me negative 14. Negative 3/2 times 14 will give me 21. I get 21 so I get a 2 here. Negative 3/2 times 2 is going to give me negative 3. This is going to be negative 14. Negative 14 times 3, negative 3/2 is the same as we did here. This is 21. So this gives me 0. This is my remainder. So now I have a polynomial here. So I have 2x to the third now, since I took out a value. So 2x to the third squared x. So this is my new polynomial. So I have this, and then my binomial that I just did. So this is equal to this. X plus 3/2 times this polynomial. Okay? So now I'm going to check this. I still can't factor this. So this is still not factorable for me. So I'm going to keep on using my list of possible rational roots. I'm going to redo the same process that I did over here. So now my s, let's use a different color. So now my s equals 2 still. So my roots, possible factors of that are still plus minus 1 and plus minus 2. My t is now, what is it? Negative 14. So my t is now equal to negative 14, which means that my b values are either plus minus 1, plus minus 2, plus minus 7, plus minus 14. Okay? And actually, this 14 will not be, well, we'll just see. We'll see what happens. So now my possible list. So I'm back to step 1 again. So my b over a. My list is positive negative 1, positive negative 1/2, positive negative 2. 2 over 2 is just 1 again, so that I don't need to repeat that. So now I have positive negative 7, positive negative 7 over 2, positive negative 14, and then positive negative 14 over 2 is just this positive or negative 7. We can actually take this positive negative 14 off the list because it was not in our original list. So we do it, not actually have to worry about that. I'll leave it there just because we can. But you should be able to say, oh, I know that this was not on my original list, therefore it can't be an answer, which is the same thing with this positive negative 2 actually. So now I'm going to do the same process. I'm going to plug these into this equation and see if I can find a root. So I'm going to do that on my calculator. If you want to do it by hand, you certainly may, but it will take you a little bit longer. This should be a positive 2x. So this is a plus 2x, and then minus 14. So I'm going to do that on my calculator. I'm going to start plugging things in. So I'm going to do 1, which is no. Negative 1 is a no. 1/2 is a no, and I actually already tested these, so they won't be roots anyway. But I'm going to do one at a time. Negative 1/2, no. I know that 2 was not on my original list, so it is not going to be a root. So I'm going to skip 2 because it wasn't a possible root earlier, so it can't be a root for the whole thing. So I'm going to try with 7 now. 7 is a 0. So I got that by plugging in simply this equation on my calculator, and I get a 0 out of it. So I know that there is a root where x equals 7. I'm going to do synthetic division again, and I'm going to pull this out, and I'm going to write it as 2, negative 14, 2, negative 14. There's actually a little pattern going on here. So I drop my 2 down, multiply it by 7, I get 14 here. So this becomes 0. 0 times 7 is 0. This is 2. 2 times 7 is 14. So this is going to be 0. So this is my remainder of 0, which means that it is a root. X equals 7 is a root, which we just proved. And now this becomes 2x squared plus 0x plus 0x plus 2. So really it's just 2x squared plus 2. This equation is the same as, so this is what we have left to factor. This is what we have left to factor. And don't forget about all this other stuff. So now we know that x plus 3/2 is a root, and also that x minus 7 is a root, okay? So if you multiply these 3 things together, you would get this original equation right now. So right now we're just breaking it into pieces. So these are already factored. Now I just need to factor this. So I have, if we simplify it, I'm left with, have my x plus 3/2, x minus 7, and then I know that I have 2x squared plus 2, which is what I have to factor, okay? Because these are already factored all the way, so I just need to worry about this part. I started looking at this, I can pull out a common factor from this. I could have actually done that earlier, it wouldn't have made a difference where you did, okay? So I'm going to pull a 2 out for both of these things. So this is going to become, actually, I'm going to simplify this. So this is 2 times x squared plus 1, okay? So I have this whole thing here. So now I'm really close to being done here. X minus 7. So I need to factor x squared plus 1. You can actually probably leave it like this, because this is almost, if we're dealing with real numbers, as close as you can get. You guys should recognize that x squared plus 1 is going to be a situation where I get my imaginary numbers that we've been working for, and this will actually, if you see it, so you can leave it like this. This is perfectly fine for what you guys are doing. X minus 7, and then 2, and then x squared plus 1 is just x plus I times x minus I. So if you did enough practice with imaginary numbers, you would be able to see that. So basically here, I have this. I know that negative 3/2 is a root now, so I found all my roots. At this point, I found all my roots. So now looking at this, I know that negative 3/2, so x equals negative 3/2 is a root. X equals 7 is a root. There's no, this 2 here doesn't really belong to anything. We can't make it 0, so we just ignore it. I know that negative I is a root, and that means that positive I also has to be a root. So these are the roots of my original equation. So I have negative 3/2, 7, and then plus minus I. So I have 1, 2, 3, and 4, which means I have found all 4 of my complex roots. I have put this in as far as I can factor it, and then I would be able to graph this using this information. So this is an example on how to find all roots of a polynomial function. We will be practicing this so that when you guys have your assessment next Tuesday, you guys will hopefully be able to do this. If you have any questions, it's a little complex, call me over. Otherwise, I hope you're able to follow along. Remember that we have a process for doing each one of these things. So that is that. Hopefully you guys are able to do this.